Namaste. I welcome you all to interesting Atharva conversation. And today I have the pleasure of having none other than Professor Mandyam Srinivas with us to talk on a very interesting topic concerning Indian mathematics and astronomy. It's said,
यथा शिखा मयूराणां नागानां मणयोर्यथा तद्वद् वेदाङ्गशास्त्राणां गणितं मूर्धनि स्थितम्.
so it's no-brainer that our civilization, our intellectual prowess, our intellectual heritage is always mapped, is always reckoned, always reconciled in the world with exquisite achievements in the field of mathematics and astronomy. There are many aspects of it which has been dealt with in detail by many researchers, but it's only the recent past that some unique facets of our Indian contribution and how it has been handled in the history, particularly in the historiographical manner, has come out in light in very recent past. And I'm glad to say that Professor Mandyam Srinivas has been one of the powerful forces in getting all these informations out in light. So we have the pleasure of listening to him directly today. It is well known that amongst the intellectual achievements of our ancient Indians, contributions in linguistics, medicine, astronomy, and mathematics are highly acclaimed. Even in that, the contributions of Kerala School of Astronomy and Mathematics are quite famous. You and your colleagues have contributed a lot to unravel the work of this school. Can you please give us a quick summary of the Kerala School of Mathematics?
It's my pleasure to discuss the recent trends in the history of Indian mathematics, especially on the work of the Kerala School. I have been very fortunate to have had the association of the late Professor V Sarma and some of the great scholars like Professor Sriram and Ram Subramanian in understanding this Kerala School of Astronomy and Mathematics. The Kerala has been a great home of mathematical sciences. In fact, the famous astronomer called Vararuchi, he wrote a set of mnemonics for discussing the motion of moon called the Vararuchi Vakyas. The 244 Vararuchi Vakyas, they are dated to around 3rd or 4th century of our common era. Later on, there have been great astronomers and mathematicians like Govinda Swami in 7th century, who wrote a commentary on Mahavaskariya of Bhaskara 1. Then Shankara Narayana, who worked in an observatory in Kerala and who also wrote a commentary on Laghu Bhaskariya of Bhaskara 1. So Kerala has had, and earlier even there was the Parahita system in 7th century. And there was also the work of Devacharya, Karanaratna. So there were several Kerala works. But what distinguishes is the emergence of a new school of mathematics and astronomy in the 14th century with Mādhava, who is supposed to have perhaps come from outside Kerala and settled down in Kerala in the 14th century. And his students, etc., set up a huge tradition and that continued till the 19th century. Now, what are its major achievements? Mādhava is well known today as the founder of theory of infinite series. He discovered for the first time in history of mathematics the infinite series for pi, the series that currently goes by the name of Leibniz, that pi is 1 minus 1/3 plus 1/5 minus 1/7, etc. Not only that, he discovered several interesting variations of that series, several interesting approximations to that series, several interesting fast convergent changes of the transformations of that series. Then he also discovered the tan inverse series, which goes by the name of Gregory today, and the sine and cosine series, which go by the name of Newton today. Mādhava was also a great astronomer. He wrote very important works on the Vakya method for finding out the moon's position called Venvaroha. Then he had a different planetary computational scheme. Again, in the Vakya system, I don't have time to discuss what the Vakya system is, called Aganita Grahachara and other contributions. Mādhava, the founder, under him learned one Parameśvara, who was in the northern bank of the river Bharatapuzha today, in a village called Alattur. Parameśvara is known to have made continuous series of observations for over 55 years. He composed about a dozen commentaries on many of the ancient works, such as Aryabhatiya, works of Bhaskara, works of Munjala, and various other Surya Siddhanta, Leelavati. But he also wrote many original works called Dhrigganita and several works on eclipses. But the famous student of Parameśvara's son Damodara was a scholar called Nīlakaṇṭha Somayaji. He lived between 1444 and 1540. He is well known for having revised the traditional planetary model of India. He changed the traditional theory for the interior planets, Buddha and Shukra, in a way that it becomes a close approximation to what we today call as the Keplerian model of planetary motion. Nīlakaṇṭha wrote several works, Tantra Sangraha, a major commentary on Aryabhatiya, a work called Jyotirmimamsa, which I will refer to perhaps towards the end. Then this original work of Mādhava and Nīlakaṇṭha got systematically sort of explained in Malayalam in a work called Yukti Bhasha by Jeshtadeva. So this is a prose work, and it's a great work in terms of like a modern textbook. It goes step by step explaining the entire mathematical theories of Mādhava and the astronomical theories of Mādhava, Parameśvara, and Nīlakaṇṭha. Similarly, Shankaravarya gave commentaries on the traditional works Leelavati and Tantra Sangraha in Sanskrit, where he brought out whatever Jeshtadeva had written down in Malayalam in Sanskrit. The tradition continued. Jeshtadeva's student Achyuta Pisharati, he was actually the teacher of Narayana Bhattatiri, the great devotee scholar, author of Narayaniyam. He lived in 1550 to 1621 in the same place where Nīlakaṇṭha was born, what's called Kundagrama, or near Tirur today. Uttumana Somayaji, who was in Shivapura, and this tradition continued up to 18th century when Shankaravarman wrote a work called Sadratnamala. So Mādhava wrote about half a dozen series and approximations to pi, and the series for sine and cosine. And you can see that many of them were redone in Europe after 200 years. And they go by the name of Leibniz, Gregory, Newton, Abraham Sharp, and others. It may be interesting to note that in 20th century, Srinivas Ramanujan wrote some very new series for 1 by pi, what are called modular series, which are used even today to find the best approximation for pi. Nīlakaṇṭha's work, Aryabhatiya Bhashya, explains his model of planetary theory in a very beautiful way. I'll just make a brief quotation from that so that we all know how Nīlakaṇṭha changed the earlier planetary models. Speaking of Buddha and Shukra, Nīlakaṇṭha says, Tayoho Brahmana Vrittena na bhuhu kabali kriyate, tato bahireva sada bhuhu. The orbits of Mercury and Venus, they do not circumscribe the Earth, or Earth is not circumscribed by the orbits of Mercury and Venus. The Earth is always outside of their orbit. As you can see, these orbits of Mercury and Venus are interior to the orbit of the Earth, whereas the Mars, Jupiter, and Saturn, they go around the Sun in an orbit which is exterior to the orbit of the Earth. So Mars, Jupiter, and Saturn, their orbits include the Earth, but the orbits of Mercury and Venus do not include the Earth. And then he explains that what is called the Shigrocha, or the mean sun, it is that which drags all the planets around. As we see from the Earth, we see all the planets go around the stars because they are being dragged around by the sun. So this was the kind of planetary model that Nīlakaṇṭha explained. And we can see that the Kerala school work from Mādhava to Achyuta, 1380 to 1575, is much before the work of Copernicus, Tycho Brahe. And in fact, the work of Nīlakaṇṭha is more accurate than Copernicus and Tycho Brahe, who were merely repeating Ptolemaic astronomy in a heliocentric framework, whereas what Nīlakaṇṭha did was the due corrections that has to be done to the Ptolemaic model so that it goes into what we today call as the Keplerian model. So this is in brief the summary of Kerala school. Today we know from the work of Sri Dharampal, his book Beautiful Tree, discusses the state of indigenous education in Madras Presidency in 19th century. And the collector of Malabar, that is what is called Northern Kerala today, from Calicut, he is sending a report in 1823 that there are several senior scholars of astronomy, metaphysics, ethics, medical science, theology, and law, that is Jyotisha, Darshana, Dharma Shastra, Ayurveda, etc. The number of students studying astronomy is about 800 in northern Kerala under these reputed scholars. The number of students studying Ayurveda is about 190, and they come from all communities also, as per the report of this Vaughan, the principal collector of Malabar, writing his report in 1850. So this was a very alive school, even in 1820s. Of course, the British rule and the policies of the education that was actively taken up by the British rulers was to see the effects of all this over the next 50-100 years.
Thank you, sir, for that overview. For the sake of uninformed enthusiasts, the Mādhava of Sangamagrama is often confused with the propounder of Dvaita philosophy, Mādhava.
Yes, yes.
There are many essays where these two names are juxtaposed. So I think through this at least exposition, once and for all clear to all these enthusiasts that Mādhava of Sangamagrama is different from the Dvaita philosophy propounder, Mādhava.
No, there are two confusions. There is Mādhava, the brother of Sayana, this Sayana Mādhava, who wrote Shankara Vijaya, or who was also associated with Sayana in the Vedic commentary. And there is Madhvacharya, who is the founder of the Dvaita school of philosophy. These two are conflated actually in even, I think, our Amartya Sen's book, Argumentative Indian. And Mādhava of Sangamagrama.
The Nobel laureate Amartya Sen.
Yes. I think these two persons' names, Madhvacharya and the Sayana Mādhava, were confused, I think, by Amartya.
Right. So thanks for that addition, sir. And as you mentioned, the Western coast was very much productive intellectually, and at the same time, there were sea trades happening, establishing contacts with the Western world, and exchanges of knowledge, either from taking from here or taking from them, must have happened during that time. Going ahead, so despite such a lofty glory of the Kerala school, were they widely recognized by the Europeans in the 18th and 19th century? For instance, one of the Europeans who had studied Indian intellectual traditions in the early 19th century is Thomas Colebrooke. He had translated the works of Brahmagupta and Bhaskara, presumably the first to do so. Did he also discuss the work of Kerala School of Mathematics and Astronomy?
Just a small comment on the contact of Kerala with the Europeans. As we all know, it was in 1498 that the Portuguese landed in Calicut. And the next 200 years were actually indeed very different and very difficult in northern Kerala. First due to the Portuguese, and then due to the advent of the Dutch. There were continuous warfare. In fact, the earlier half of the Kerala school, it was divinely blessed, with there being only the older seaborne trade, which was supervised by the Samudrin Raja, who we call Zamorin today, of the Kozhikode. But this was a very difficult time. So in fact, to some extent, the sort of coming down of the activity of Kerala school, after 1550 or so, after Nīlakaṇṭha's death, though I have mentioned so many other names, they are not as legendary as Mādhava or Parameśvara, Nīlakaṇṭha or Jeshtadeva. And that is more due to the real fact, the factor that Kerala indeed became a very major battleground. And that went on till actually end of 18th century with Hyder and Tipu coming to northern Kerala and all that. Anyway, now coming to the modern Europeans, when did they come to know of Kerala school work? There has been a hypothesis that this Kerala work on infinite series, and perhaps even the Kerala work on the change of the traditional planetary model to a quasi sort of heliocentric kind of planetary model, was perhaps communicated to Europe by the Jesuit scholars who did come to Kerala in early 16th century, following the Portuguese arrival there. But we have not yet been able to actually find any textual references of the Jesuits trying to find out the Kerala school work. Matteo Ricci, who came to Kerala and later on went on to China, was responsible for communicating some of the developments in European astronomy at that time to China. But there are still no records which we have unearthed to show that Matteo Ricci had taken some bits of Kerala School of Astronomy and communicated it to the European scholars. There was continuous correspondence between the Jesuits and their European sort of organizations. That is very well known. In fact, that is very well documented. But on Kerala astronomy, whether there has been some communication, no documents have been unearthed. There have been earlier transmissions about which we know. Anyway, we will come to that if necessary later. Now about Henry Thomas Colebrooke, he is known as the father of modern British Indology, and he was here in various capacities from later half of the last quarter of 18th century. So in 1817, he wrote a very important book called the Algebra and the Mensuration from Bhaskara and Brahmagupta and Bhaskara. And he wrote a very detailed introduction. He translated the 2 chapters of Brahmasputa Siddhanta, which deal with mathematics, called the Ganitadhyaya and the Kutakadhyaya. And he translated the 2 great mathematics works of Bhaskaracharya too. Brahmagupta lived in 7th century. Around 628, he wrote his Brahmasputa Siddhanta. Bhaskaracharya wrote his Lilavati and Bijaganita in around 1150. So all these were translated with some notes and explanations. But at the time, Colebrooke could not even get any work even of Aryabhatta. He was mainly based in North India, Bihar, Banaras, and Calcutta. And since the communication in India had gotten sufficiently disrupted during the Mughal rule between South and the North, and since Bengal itself was under Muslim rule for over 700 years, it was not very easy that they were able to get all the latest works. When Aryabhatta sort of work was there, within about 100 years, a commentary or a work based on Aryabhatiya was written in Kerala. And within even 30, 40 years, Aryabhatiya was referred to in the Western India by Varaha Mihira and other people. But so, no such situation prevailed in 17th, 18th century. Anyway. Now, Henry Thomas Colebrooke did not refer to the Kerala works on astronomy at all. He did not know this kind of work. He spoke about the high achievements of Indians in algebra, since he translated Brahmagupta and Bhaskara. But even there, since Colebrooke himself was not a great mathematician, trained as a mathematician, he was unable to appreciate the fact that this solution of this, what we today call as Peltz equation, or what Brahmagupta introduced as the Varga Prakriti equation, whose systematic solution was discovered in India by Jayadeva around the 9th or 10th century, and which is discussed in Bhaskaracharya's Bijaganita, that is called the Chakravala method. But Colebrooke could not understand that this Chakravala method was different from the way this equation was being studied in Europe in 17th and 18th century. Fermat posed this equation as a problem to British mathematicians. And one of the examples that Fermat asked them to solve is actually a solved example in Bhaskara's Bijaganita. So again, whether there was a transmission from 1150 Bhaskara's study to Europe, we don't know. Then after that, Lagrange and before him Euler came up with a method of solution of this equation. And that is by the method of continued fractions. But they used what is called a regular continued fraction. But what Bhaskara is using, it was shown in 1920s and 1930s by some of Indian scholars, especially Professor Krishnaswamy Iyengar, that Bhaskara's method was much more optimal. It uses only 70% of the number of steps that are involved in the European method of Euler and Lagrange. So all these things couldn't be appreciated by Henry Thomas Colebrooke, though his was a pioneering work in making the European world aware of all this. There were one or two translations of these books. One, Leelavati, was translated by Taylor, and I think the Bijaganita was also translated by another European scholar, just 1 or 2 years prior to Colebrooke. But Colebrooke's work is much more scholarly and fairly reliable. But his knowledge of the intricacies of Indian mathematics would not still be deep enough. He was the first scholar to get into this subject with some amount of seriousness.
Getting involved with this Indian work with some amount of seriousness, what was the motivating factor? Was it the curiosity to know about the Indian mathematics, or is it some kind of drawing parallel between the European intellectual and the Indian intellectual? Just if you may briefly comment on that.
No, this is an issue even before Colebrooke's work, starting from about mid-18th century. Various European observers came, and European officials also came, because Britishers started ruling large parts of North India. And even earlier, Portuguese and Dutch were ruling in South India. So at that time, Europeans were really looking for detailed knowledge, especially in technologies from India. In sciences, they thought that they had reached a peak after their scientific revolution in late 17th and 18th centuries. But in technologies, they were looking for very detailed knowledge. And in other sciences, so scientific revolution did not come up in botany or zoology or things like that. So we know Dutch governor, Van Reed, got 12 volumes of Hortus Malabaricus, where he got the Indian botanists in Kerala and Indian Vaidyas in Kerala to tell him in detail, along with the diagrams, the understanding of various plants and their medicinal and other uses. So this had great impact on European development of European botany, of Linnaeus and others. But they were not looking for some such thing in astronomy and mathematics. But they knew that India had a great reputation as a home of mathematics and astronomy from the early Middle Ages, because the decimal place value system had gone there. So they were looking at all these things. Technology, especially, they were looking for interesting new methods of steel making, or in medicine, in surgery, and things like that. There are several accounts. Many of them have been reported in books of Dharampal and various other scholars. Colebrooke was more looking at the origin of modern mathematics, whether it should be credited to the Arabs or to the Chinese or to Indians. I mean, in his preface, that is the question he's talking. And he comes to the conclusion that Indian algebra is much earlier than the algebra of the Arabs. But he still wants to think that the Indian algebra somehow got and transmitted to the Indians from the Greeks, because that was the model that of historiography that Europeans were sort of saddled with it. Even today, that's more or less their approach to looking for it. So he's trying to look for some parallel with Diophantus, etc. He's unable to find any concrete examples, but that is what he's looking for.
In line with that historiography, my next question, where in the recent article, your article, I quote, "Emergence of a new era in the history of Indian mathematics," unquote, published in the January 2022 issue of the journal Bhavana, you have discussed in detail the modern historiography of Kerala school during the last 2 centuries. To start with, when did the European scholars first take note of the knowledge of infinite series among the Indian practitioners of astronomy and mathematics? And if I may also add, in your exposition, when you had also mentioned that the Grigori series, the tan inverse series, and the sine and the cosine series, the Newton series, which were all propounded or discussed by Mādhava, of course, the representations were different. So,
yes,
over to you, sir.
Okay. It was generally thought that Charles Whish, who published an article in the Transactions of Royal Asiatic Society. The article is called "On the Hindu Quadrature of the Circle." So this was the first article where the Indian knowledge of infinite series was reported in a scientific publication done by a European. But today, by looking at the various sort of works of the period, we can see that European appreciation that Indians know some infinite series, or there are astronomers and mathematicians in India who can use infinite series and who know several of them. This knowledge seems to have been there among many European observers around 1820. A very interesting record of that is a book called Kālasaṅkalita. This was written by a Frenchman called John Warren. He was for some time a astronomer who was heading the observatory in Madras city. So this book is published in 1825. And Warren says he saw a native astronomer who was a perfect stranger to European geometry, who gave him the well-known series 1 minus 1/3 plus 1/5 minus 1/7, etc. for pi by 4, pi being the ratio of the circumference of a circle to its diameter. Then in the same book, Warren puts a small footnote, and this footnote is very interesting. This book is published in 1825, and then he says, I have received this small note by Mr. George Hyne. George Hyne was in the British medical service, but he was an important authority in the Madras Literary Society, which was started in 1820. So George Hyne is telling Warren that the Hindus never invented this series. It was communicated to them with many others by Europeans. Mr. Whish, Hyne is saying, Mr. Whish sent a list of various such series to the Literary Society, being impressed with the notion that the Indians were their inventors. I requested him, that is George Hyne requests him, to make further inquiries. And his reply was that he had reasons to believe that these series were actually modern and derived from Europeans. So George Hyne concludes by saying, indeed, the pretensions of the Hindus to such a knowledge of geometry is too ridiculous to deserve refutation. Then this Warren's Kālasaṅkalita has an appendix where he has listed another letter from George Hyne, where he is listing these 7 infinite series that were sent perhaps by Charles Whish in his communication to the Madras Literary Society. So in 1825 already there is some debate going on between John Warren, George Hyne and Charles Whish that the Indians have had some knowledge of infinite series. Now George Hyne is the proponent of the view that this has been communicated to Indians by the Europeans, and he has managed to sort of convince Charles Whish that perhaps that is correct. So this was the situation in, as we see in John Warren's book. Now about your comment that these series are looking different in the way they were discovered in Europe and in the way they were discovered in India, it's not really all that different. Indians did use a whole lot of symbolism starting from the time of Brahmagupta in algebra, though they did not use all the symbolism that was invented in Europe in 16th, 17th century. Europe invented all the algebraic symbolism in the 16th and 17th century. Indians they were the originators of algebra. They were dealing with algebraic polynomials. If you look up Bhaskara's Bijaganita with his own commentary, you will see continuous set of symbols and equations and equations and equations written in symbolic form. Of course, the Europeans in 16th and 17th century took it forward by more systematic symbolism. Indian results were all conveyed in verses or in sentences, but they were very precise and very exact so that you could immediately write down what the equation is. So this 1825 can be taken to be the time or around 1820s when Europeans first became aware of it and recorded this fact that many of the Indian astronomers are aware of infinite series, though they doubt, especially somebody like George Hyne says that this is too ridiculous to think that the Indians themselves have come up with this knowledge. It must have been communicated to them by the Europeans. And this issue will persist after the publications of the articles of Charles Whish.
So which brings to the obvious next question, that how Charles Whish came to know about the famous texts of Kerala school, or how did he manage to publish a few articles on this tradition? Because
Charles Whish is yes.
Given that they are all in Malayalam, the terse language.
Yes. So the works of Kerala school are both in Malayalam language and in Sanskrit language. Mādhava's works are all in Sanskrit language, or his available quotations about infinite series are all verses in Sanskrit. His books, Venvaroha, Sputa Chandrapti, Aganita Grahachara, these are the known works of Mādhava, Madhyamanena Prakara, Mahajyanena Prakara. These 5 works of Mādhava, they are all in Sanskrit. Parameśvara's most of his works are in Sanskrit. But it is Jeshtadeva's Yukti Bhasha which is in Malayalam. Then Jeshtadeva's pupil Achyuta Pisharati writes lots of Malayalam commentaries to earlier works of Mādhava and others. So like that in Kerala, from about 1520, 1530, writing works, technical works in mathematics and astronomy in Malayalam becomes very common and becomes fairly advanced. The other thing is they are all written in Malayalam script. As you know, Sanskrit is written in different regional scripts in different parts of India. Now, Charles Whish is 1794 born. He comes to India in 1812. In 1813, he is sent to Malabar, that is northern Kerala, as a writer. Then he continues there, he is registered, then assistant judge. Then till 1830, so for about 15, 16 years, he is in Malabar. Malabar means today's all the districts upwards of Palakkad till Kasaragod. That entire region is called Malabar in 18th century or early 19th century. He is briefly out of employment in 1831. That's very intriguing actually. Then he is transferred to Kadapa in 1830 and he suddenly dies in Kadapa in 1833. Now, so he has spent 15 years in Malabar. He is supposed to have written a Malayalam grammar and dictionary, which I have not been able to locate. He collected around 300 Malayalam and Sanskrit manuscripts of very important literary, philosophical and scientific works. Vedic corpus, Mahabharata with commentaries. Very interesting, lots of works are there in the Whish collection. After his death in 1833, they were all donated to Royal Asiatic Society in London by his brother, John Whish. In fact, 2-3 brothers of Charles Whish were also in East India Company service in India. He is, I think, the 11th son or something of his father. Now, the first indication of Whish having come to know about Kerala work is actually in an unnumbered manuscript, a notebook, which is there in Royal Asiatic Society. It's a notebook. On the right-hand side of each page, he has transcribed a commentary called Kriya Kalapa of Shankara Warrior on the famous work of Nīlakaṇṭha called Tantra Sangraha. But Whish doesn't know that this commentary, Kriya Kalapa, where it is Malayalam, where it is Sanskrit, he is perhaps not able to distinguish fully. Now, this notebook has a signature of Charles Whish and mentions the date 1820. So perhaps he started. So on the right side, he writes this Tantra Sangraha with Kriya Kalapa commentary. On the left side, he is writing his own notes in English. So words after words, he tries to write his notes and sometimes you can display them. I have these diagrams here of its pages from this unnumbered manuscript notebook of Charles Whish. So he started learning all this in 1820s. And so this paper that communication that George Hyne is referring to as published in Kālasaṅkalita would have been sometime in 1823 or 24 he has communicated an article. But at that time, that article is sort of rejected by Madras Literary Society. But Charles Whish persists. And so his first publications are in the first issue of what is called the Transactions of Madras Literary Society. He has 2 papers in that. But they themselves are very interesting. The first paper is called Alphabetical Notation of the Hindus. And there he is explaining this Aryabhata system of numeration, the Bhuta Sankhya system of numeration, and the Katapayadi system of numeration. And he gives the example of Shankaravarman's verse in Sadratnamala, where he is using this phrase, Badram Buddhi Siddha Janma Ganita Shraddhasmayad Bhupagi. This long phrase is supposed to convey the number 314-159-265-358-979-324. This is the circumference of a circle whose diameter is 10 to the power 17. So this is giving the value of pi correctly to 17 decimal places. So he's giving this. He's also giving a very interesting collection of verses of Mādhava, which gives the what is called the value of sine correct up to minutes, seconds, and thirds. So it's a very accurate sign table of Mādhava. So these two things he's giving. If anybody had read this, immediately they would have gotten the question, how did Indians get such advanced mathematics to be able to calculate 5 to 17 decimal places and things like that. The second article of Whish is somewhat more interesting. Because he had this sort of rebuff from George Hyne, he tries to sort of please the British establishment by writing a paper. And in this paper, he wants to show that the system of Rashis, are called zodiacal signs, are not there in older Indian books, and they have been borrowed by Indians from the Greeks. And he wants to contest the statement of William Jones, which he had made in an article in 1790, that Indians would not like to borrow from anybody else, from the late Charles, etc., etc. He wants to show that Indians have borrowed this idea of the Rashis, the Mesha Rashi, Vrishabha Rashi, etc. The reason is the corresponding Aries, Taurus, etc. There is a correspondence. And many times the corresponding European words are occasionally used in some works of Indian astrology. This is the first article trying to show that. So by this, in some sense, he gets rid of the sort of inhibitions that George Hyne and others had. But anyway, George Hyne dies in 1826. So Whish is more free. So he somehow prepares this paper over the next 6-7 years. And then he sends it to the Royal Asiatic Society through the Madras Literary Society in 1830. So what happens is, this Royal Asiatic Society is set up in London by Colebrooke. Colebrooke returns to England after 1818, and he sets up this Royal Asiatic Society in 1823 as the premier institution for studies of all Asian civilization, especially India, premier institute of Indology. And the original Calcutta Asiatic Society and the later Bombay branch of Asiatic Society and this Madras Literary Society are all become affiliated societies to this Royal Asiatic Society in London. Then that itself holds, the king is the patron, it holds regular meetings, etc. And so this paper of Whish, he is not going to England, but this paper of Whish is communicated to Royal Asiatic Society from Madras, and it was read in the meeting of Royal Asiatic Society on the 15th of December 1832. That is what is actually inscribed on the paper when it is finally published. The Royal Asiatic Society transactions start publishing in 1825 or 26. This is the third volume. The third volume is published in 3 parts, 1831, 1832, and 1834. Whish's article appears in 1834. Then all these 3 parts are bound together, and it is finally dated 1835. So about the date of Whish's article, there are 3 dates. One is 15th of December 1832, when the paper was actually read in London. Second is 1834, when the corresponding volume was published. And third is 1835, when the 3 parts of the third volume of Transactions of Royal Asiatic Society are bound together and dated 1835. So Whish dies actually within a few months of his paper being read in London. He dies in 1833 in Kadapa. There's actually perhaps a notice in the cemetery in Kadapa. I have seen the report of it in some of the British papers. Now coming to Wish's third main paper. The main paper is called On the Hindu Quadrature of Circle. And there he says the Hindus have an independent way of doing this theory of fluxions. Theory of fluxions is what the name given by Newton's to his calculus. And they are able to discover all these infinite series. They are able to get several series for pi, the Gregory series, the sine series, cosine series. These are all series discovered after 1660s in Europe. And then he says that in a separate paper, I will give this paper actually refers to 4 texts of Kerala. In the Shastras of Tantra Sangraha, Yukti Bhasha, Karana Paddhati, and Sadratnamala. 4 texts of Kerala. Tantra Sangraha is the book written by Nīlakaṇṭha, I mentioned. Yukti Bhasha is the Malayalam work of Jeshtadeva, which gives all the proofs. Karana Paddhati is a very special text on the Vakya method, which was written by Puttumana Somyaji, perhaps in end of 16th century or beginning 17th century. Sadratnamala is the work written in 1819 by Shankaravarma. And Whish actually mentions the name of Shankaravarman and says he is a very proficient astronomer and mathematician and all that. Which also talks about a college which was functioning in Kerala. So all this he says in this paper, and he says, a further account of Yukti Bhasha, the demonstrations of the rules for the quadrature of the circle by infinite series, with the series for the sines, cosines, and their demonstration, will be given in a separate paper. But unfortunately, he didn't live to write that separate paper. So in Whish manuscripts, there is a very interesting manuscript. In the 300 manuscripts of Whish, which are deposited in Royal Asiatic Society, there is a manuscript number 124. And this manuscript is called Tantra Sangraha Valiya Bhasha. Valiya Bhasha means extensive comment in Malayalam language. Now, on the first folio of this manuscript, Whish has inscribed something in English for people to see. The Tantra Sangraha Valiya Bhasha, rather the Yukti Bhasha, containing the demonstration of the author's infinite series in the Tantra Sangraha, Charles N. Whish. Why is he doing this? Because I think from the time of George Hyne, when he sent his first paper to Madras Literary Society, the question was, okay, you say they know this infinite series, but can they tell us the proof of this infinite series? Do they really understand that? So this was the question that George Hyne said. I asked Whish, and he therefore got convinced that maybe it is not their discovery. So later on, Whish has convinced himself fully that Yukti Bhasha has all these derivations, and therefore he wants to put it down on the manuscript. There is some problem, health problem that Whish is facing, that in 1831 he is out of service. Whether it is actually a physical problem or mental problem, I have no idea. We'll have to do much more research to see if there is some indication of his own personal life at that time. And so this he puts, and this is there actually in that manuscript even today. And again, as our story goes, this was refused to be taken note of by all those people who did cataloging of the Whish manuscripts in the 19th century. So this is the story of Charles Whish and his. Unfortunately, he didn't live to write down the next paper, and his paper of 1832 talk and 1834 publication was available in the most famous journal, Transactions of Royal Asiatic Society of London. Colebrooke was alive till 1835, I think, or 1837. So this paper would have obviously been seen even by Colebrooke and would have passed through the sort of all the editorial supervisions that the Royal Asiatic Society should have done.
Very interesting snippets in your answer, and that also surfaces about the culture of proof in the Indian mathematics, on which you have also previously dealt very extensively. Despite the publication of Charles Whish paper in 1835, there is absolutely no mention of this mathematical contributions of the Kerala school in the modern scholarly literature for the next 100 years, that is from 1835 till perhaps 1935. How has this been explained or rationalized by Western historians of Indian science, prominent among them being the American historian of mathematics, David Pingree?
This is the very interesting story, and perhaps this may be a typical of whole of European Indology, what was done in the case of the Kerala work on calculus. This now everybody knows that till 1930s, 1920s, there was no discussion of the Kerala work in histories of mathematics, and there were no articles written on it. And in a talk which he gave in Harvard University in around 1990s on Hellenophilia versus history of science, David Pingree tried to mention 2 points. First is he wants to make a point that what Mādhava is doing is not calculus. He is using some algebraic and geometric methods to get these infinite series. We will not discuss this question right now. Let us come to that later. The second thing he says, but in 1830s, when Charles Whish paper was published with all these infinite series, they couldn't have been discovered without calculus. At least that is how that was the European view of the time. So Europeans were stunned. This claim that Whish's paper shows that this was indeed calculus. So presumably they were ignored, he says, first because they could not admit that Indians, an Indian discovered the calculus. But second, he says, later because no one read anymore Transactions of the Royal Asiatic Society, in which Wish's article was published. So these are all very careful phrases that David Pingree is using. So he says nobody read Transactions of Royal Asiatic Society. And of course, they were shocked by the fact that an Indian discovered calculus. So for both the reasons, the article was never looked into. So first thing we should see about this issue is the talk that was given in Royal Asiatic Society in 1832 was widely reported. In fact, within about a week of it, there's a report of this talk in something called the London Literary Gazette, where they is telling in great detail the work Tantra Sangraha, the value of pi to more than 10 decimal places, and the kind of infinite series that are there. And even the title of Yukti Bhasha is mentioned and proofs are mentioned. Similarly, there were two other journals, Royal Asiatic Journal and I think Gentleman's Magazine. They also carried a report in early 1833. But more than that, within a few years, many scholarly articles took note of Charles Whish's paper. Lassen is a very important Indologist in Germany. He wrote an article on Indian way of representing numbers. There he is referring to actually Whish's 1834 Transactions of Royal Asiatic Society article in an article in 1837. Similarly, in a bibliography on Indological works, Charles Whish's article and the text Tantra Sangraha, Yukti Bhasha were all mentioned in 1838. And more interestingly, even there were a son and father couple called Rigaud, S.P. Rigaud and another Rigaud. They wrote 2 volumes on the correspondence of Isaac Barrow, Flamsteed, John Wallis, and Isaac Newton, the major calculus and astronomy people. And in that, he suddenly, in volume 2, he's taking note of Whish's paper, mainly in the context of value of pi that is given there, which was found out by Wallis by some other method. John Wallis in 17th century, around 1650s. He gives an infinite product representation for pi, John Wallis. So what are the values John Wallis is getting? He is referring to Whish's paper to show that it is actually there in Tantra Sangraha also. So within the first decade of the publication of Whish's paper, it has astonished people. It has been taken note of very seriously in scholarly circles. And Transactions of Royal Asiatic Society was the premier journal. So if this whole paper is soon to be forgotten, or if there is no further discussion of it, if there is going to be silence on it, we have to look for the reasons elsewhere than in the kind of argument that David Pingree wants to make.
It's as you said, it's like using very careful words, diplomatic words to cover up the lapse. Because back then, given the prominence of the journal and given the lack of mushrooms of journals that we have today, it is definitely out of question that people would not have taken notice of it. So that argument is clearly, it's a weak argument. And as you said, we have to look at other possible reasons why this was being not looked upon. Otherwise, the vested interest is one of the reasons that they want to really suppress the Indian achievement of that time. You have highlighted the fact that Augustus De Morgan, a leading light of the British mathematical establishment, as being responsible for dismissing the claims of Indian discovery of infinite series as a clever forgery. This is really surprising, as De Morgan has often been hailed for his progressive views and also as a great promoter of Indian scholarship, as he got a book of Yashodhian Ramachandra on Maxima and Minima published in London in 1858, along with a glowing preface. Can you please elaborate on De Morgan's writings on Indian mathematical and astronomical tradition?
This is indeed a very sad story. Augustus De Morgan has links with India for 2 generations. He himself was born in India. His father was and his grandfather served in India. And Augustus De Morgan was an important member of the European and British mathematical establishment by 1840. And there is something called Penny Encyclopedia. There are several big volumes of it. And he is part of this movement of widely disseminating knowledge through this encyclopedia movement. In that sense, he's one of the progressives who is sort of taking, I think this encyclopedia movement started in France, and later on people like De Morgan, etc., started that kind of a movement and this is a more common people's encyclopedia. So that's why it's called penny encyclopedia. So Augustus De Morgan writes an article. He has written about 300, 400 articles in that encyclopedia, mostly covering modern mathematics and explaining it in simple terms for many people to see. He wrote many very nice, well-known textbooks of mathematics. His preface to Yesudian does not mention Kerala mathematics at all. This Ramchandra was in Delhi, and he wrote this book on maxima and minima. He gets converted to Christianity sometime later, in early 1850s. And this book is published again in London by De Morgan. He writes a good preface where he says that this algebra is well known in India, Bhaskara, Brahmagupta, and their work is well known. And Ramchandra is trying to use it in an interesting way for doing some simple calculus problems of maxima and minima. It's very interesting. But he mentions no word on the Kerala work on calculus in this 1858 treatise. But he writes an article in 1843 in Penny Encyclopedia. The title of the article is called Viga Ganita, V-I-G-A. V-I-G-A is a bad spelling for Bija Ganita, actually. This Va was wrongly being used even by Colebrooke in 1817 instead of Ba in many of its transliteration. So this is the only article De Morgan has written on Indian astronomy and mathematics in this entire, I think it's about 30-volume encyclopedia. This appears in the 26th volume. There, it's about 8-page article. First 5 to 6 pages are devoted to an important debate that took place in Europe in 1770s, 1780s, and till about 1810 on the ancientness of Indian astronomy. There was a school of French scholars led by John Daly, who wrote a treatise on Indian astronomy based upon some of the tables that the Jesuits and others had sent to France. And he claimed that some of the results there indicate Indians' calculations are very accurate, even in 3000 BCE or things like that. So since they didn't have a very sophisticated astronomy, it must have been done by observation and all that. Anyway, today we know that there are many observations done in India which go back to the 3rd millennium BCE. For instance, the observation of the pole star Abhaya Dhruva, which has been recorded both in Taittiriya Aranyaka and Brahmanda Purana. And this Abhaya Dhruva occurs in what is called the Shinchumara constellation. Today we call that star is called as Alpha Draconis. We know today that this was the pole star in 2800 BCE. And after about 2300 BCE, there was really no star which is located near the North Pole till our recent times, when we know that this Alpha Ursa Minoris, which is the current pole star, this is the star near the North Celestial Pole. This is due to the precession of the equinoxes and all that. So, but there is a very important observation recorded in, this was written in a couple of papers by Professor R. and Iyengar of Bangalore, that the Dhruva, Abhaya Dhruva, the Alpha Draconis, was recorded as the pole star in Indian text, in Vedic corpus, in Puranas, and there are several other places where it has been recorded. But anyway, this debate was taking place in Europe, whether Indian astronomy is ancient or not. Later on, Laplace tried to prove that all those records do not refer to an ancient period. So the ancientness of Indian astronomy cannot be taken for granted. This was the conclusion. Now, De Morgan is going through this debate and summarizing all this for 5-6 days. Then suddenly he writes one page on Bhaskara's algebra and Bhaskara's Nilavati, Bijaganita, and then half a page on Indian trigonometry. Then he says, in recent times, most people say Indians have very little of mathematics. And I also go with it, except for this recent article of Charles Whish. This article of Charles Whish, if anyone whose name was not known to us had simply published this paper on his own authority, we should have had some suspicion that it was neither more nor less than a clever hoax. But it is published with the Sanskrit at full length in the memoirs of the society, which is best able to judge of its contents. So De Morgan is very clever. So he says it is looking like a hoax, but it is published by a very important journal. Then he wants to give some argument. from the article itself to show that there are reasons for which one should be suspicious. There is one strange statement in Wish's article of 1832, 34, 35, that article which was read in 32, published in 34, where he says that these infinitaries are not known outside of Kerala area. This is said in Wish's article. Whereas the fact that I mentioned John Warren having met an astronomer who knew the infinite series. John Warren never went to Kerala. He was in Pondicherry, he was in Madras. And even in older times, there is a correspondence between Nīlakaṇṭha Somyaji and an astronomer called Sundar Raja in 16th century, who was in Kanchipuram. And there is a work called Sundara Raja Prashnottara, which Nīlakaṇṭha is supposed to have written to satisfy Sundar Raja's query. So this is all hogwash, that this is not known outside of Kerala, etc. There are manuscripts in Telugu script of Kerala works. And there is a Sanskrit version of Ganita Yukti Bhasha, which Professor K. V. Sharma has published. So there are various reasons we can see that this was known, at least widely in South India, that one can conclude. So De Morgan uses this argument to say that this Kerala was in touch with various Westerners and they must have obtained it. So he first says Lee Gentile, who came to India in 18th century, he must have transmitted all this. And then he says some more series maybe would have been communicated by later Catholic missionaries, might have given the rest of them to India. So he writes about 3-4 paragraphs of this kind of an argument to show that Wish's article is all very suspicious. He of course says that we will have to check the original sources and see whether the dates are correct and all that. But it's all very suspicious. And he leaves it at that. But he uses the word clever hoax in the very clear. And very surprisingly, after 15 years, there is a British Encyclopedia published, where De Morgan again reproduces his Viga Ganita article. But these 3-4 paragraphs which refer to Charles Whish's article are removed from it. So he first takes note of it and raises various kinds of doubts and shows him this idea that this is not genuine. And then he even removes the reference to that article in a later version of encyclopedia. Once it is ensured that people have stopped talking about it, there is no need to further beat the sleeping dog. So the issue has sort of gone underground. So there is no more need to do it. I mean, this is a very, very fishy kind of operation by Augustus De Morgan. There are many people who think that Augustus De Morgan was a friend. I mean, he was of course a friend of George Boole and George Everest. And it is many times thought in Mary Boole, she has written various articles that George Everest took various aspects of Indian logic and taught it to Boole and De Morgan. And therefore they took this Indian knowledge and they were able to develop modern logic and all that. It is true that Navya Nyaya has a different version of what are called the De Morgan laws, the association of intersection with union, the distributive laws of intersection and union with respect to intersection and union. Those are called De Morgan laws, and or being distributive. And that is there in the Navya Nyaya treatises of 15th, 16th century, Raghunatha Shiromani and later. Anyway, but this is very fishy what Augustus De Morgan has done. I can see that. He even removes the entire portion from the 1858 version.
Perhaps there would have been an epiphany in him which made him remove that, or as you said, he is really not willing to beat the sleeping dog and wants to completely censor it out from the public knowledge. So that
no,
explains.
I think because when De Morgan says these works should be looked into, in fact, he says somewhere that on this point we may suspend our opinion till these works are published. So if he was so clear, Wish's manuscripts were in London after 1836, anybody could have started looking at them and published some of them. And then one could have. So it's actually a sort of a very, very, I would say, suspicious and fishy operation that we really don't believe Indians have done this. But why get into this? I mean, it's over. I mean, they might have done, they may not have done. They really don't deserve the calculus even if they have discovered it.
Adding further to the suspicion or adding more muddiness to the already muddied water is another character, C.P. Brown. And you have also mentioned that in the 1860s, C.P. Brown, that is Charles Percy Brown, a major British scholar administrator in India, castigated Wish's paper as quote unquote fraudulent documents. And just like our Indian attitude of venerating all the Goras, C.P. Brown is otherwise venerated as a redeemer of the Telugu language, for he has also been declared as the Andhra Bhashodhadara. So can you explain his opinions, C.P. Brown's opinions on Wish's paper?
C.P. Brown is well known for many historical writings on inscriptions, and of course for grammars and other linguistic works on Telugu language. He was also an important administrator in India. After retirement, he went to London as a professor. So just as De Morgan is a very important man in the British mathematical circle, Charles Brown is a very important person in the official and administrative scholarly circles of South India. And he writes a book called Carnatic Chronology, where he starts a section called Fraudulent Document. And there the first document he talks about is the article of Charles Whish. And he refers to De Morgan's Viga Ganita. So whether De Morgan's article, he tries to sort of qualify by saying one would have called it a clever hoax or things like that. But Charles Brown clearly understood that De Morgan is calling this a hoax. Therefore, he is writing the article Viga Ganita in Penny Encyclopedia, having mentioned Wish's discoveries with a surmise that they may be forgeries. I offer the following description of their origin. So what Brown does is something even more fantastic. He says he knows one Vishwambar Shastri in Madras College. And this Vishwambar Shastri is one Ayya Shastri, who was there in Tanjore earlier and who knew Wish and all that. And it is Ayya Shastri who composed all these verses and gave them to Charles Whish. And this Ayya Shastri used to laugh and joke at the whatever credulity of these Europeans or whatever gullibleness of these Europeans, things like that. So he has written 3 paragraphs on that. And in the end, he says C.P. Brown is such a poor scholar of this subject. He doesn't even know that Tantra Sangraha could be a text of astronomy. So he makes a joke, what is this Tantra Sangraha? What kind of Tantra is it? So he confuses with the Tantra literature, whereas in the astronomical literature, Tantra is one kind of work, like Siddhanta, Tantra, Karana are 3 genres in astronomical literature. He doesn't know that obviously. So he makes fun of it and all that. And he says some of his manuscripts are there in London, which is manuscripts. They should be transferred. They're all in Tamil and Malayalam. They should be transferred to Government Oriental Manuscripts Library in Chennai. So again, he has also done the same job of, if anybody even happened to by chance look at Wish's paper, he should be cautioned that this is a very suspicious and this is a dishonorable thing. This is something that doesn't need to be touched by people who are more serious and people who are well grounded in proper historical and scientific methodology. This is what is being achieved both by De Morgan in the history of mathematics community and by Charles Brown in perhaps in the larger Indological community.
This major quip by C.P. Brown only reminds me of a light-hearted joke shared among mathematicians, that how the word field is understood by differently by mathematicians and non-mathematicians.
Yes.
I think it is similar allusion here that is happening.
Ring also has a mathematical
ring
connotation
also.
and non-mathematical connotation.
That is right. And now the next question is also centered around the Wish's paper itself. That what is the story of this Wish manuscript, which seemed to have included many of the texts that were discussed in his paper, especially the renowned Yukti Bhasha in Malayalam, which has all the proofs of the infinite series, etc. Since both De Morgan and Brown mentioned that the original text should be looked into, did the high Indological scholars in Europe show any interest in getting these manuscripts catalogued and studied?
This is again one more sad history that we have to recount of the high bias of the European Indological scholarship. The Wish manuscripts are put there, and the report that these 300 manuscripts are there, that report doesn't even mention the subject astronomy and mathematics. It takes many manuscripts on epics, Puranas, Vedas, and all that were donated by the brother of Charles Whish, who was in Indian service. Then later on in 1860s and 70s, there are the secretary of Royal Asiatic Society gives a talk where he refers to Whish manuscript. There he takes note of the fact that there are some astronomical and mathematical works are there. They need to be catalogued still. So De Morgan's article and Charles Brown's article have no impact on anybody. They have only impact to put people away from taking Whish article seriously. They do not induce anybody to look at these manuscripts or catalog. Of course, they were preserved properly. So it's in 1880s, some hand lists are made and they're published in Royal Asiatic Society and other places. So the first catalog was done and published in 1902 by a very reputed Indologist, Moriz Winternitz. He is an Austrian and he has written several volumes of history of Indian literature with one exclusive huge volume on Indian scientific literature. And this was published around 1910 to 1920. In fact, this was considered one of the most scholarly histories of Indian literature. Later on, John Gonda has edited after 1960s another series of this history of Indian literature in several fascicules. I don't know whether you have seen. There's a volume by Matilal on Nyaya, there's a volume by Sharpe on Vyakarana, there's a volume by Pindri on Jyotish Shastra, and like that. Somebody was to write a volume on medicine, it was not written. Anyway, it goes from Vedas up to Indian language literature. So it's a very detailed, about 20-30 volumes have been published by John Gonda as a new version of Moriz Winternitz's History of Indian Literature. So that is the level of sort of adulation that they hold Winternitz. Now this Winternitz goes and catalogs. One thing he does is he does not catalog the Malayalam language manuscripts. The manuscripts whose language is Malayalam is not catalogued. All manuscripts are in Malayalam script. 95% of the manuscripts are in Malayalam script. 5% are in Grantham script. And in fact, he says there is nothing in Telugu or Kannada script. Therefore, they are mostly Whish manuscripts are in Grantham or in Malayalam script. So only the Sanskrit works are catalogued and 300 works are catalogued. And in that catalogue, you do not find the name Yukti Bhasha. You find Tantra Sangraha only once, its commentary being mentioned. But writes 200 pages on history of Indian scientific literature in its history of Indian literature. He does not take note of Tantra Sangraha or any of the scientific works in Whish manuscript. So, though Moriz Winternitz catalogs the Whish manuscript in 1902, it is published. By looking at it, you cannot even guess that Yukti Bhasha is there in Royal Asiatic Society. And if he had just done, in fact, there are only 15 manuscripts which are in Malayalam language. And so if they were added to, in fact, once he is able to read Malayalam script, he can very easily catalog the manuscripts in Malayalam language also. And he would have seen then if a descriptive catalog was done, what Whish had written in the second folio of his manuscript had to be put in there. That this is the manuscript which contains the proofs of all the infinite seeds. So this is again another very shady operation done by reputed European Indologists, which we have to really understand how such things happen in the field of European Indology. Today, all these manuscripts are available online, so you can download them and see all of that.
Till now, I mean, there have been the benefit of doubt or some fishiness that has been there. Do you have also some instances of willful neglect by the Western Indologists and historians of mathematics who chose not to discuss the work of Kerala school, and even when they refer to articles of Whish for one reason or the other?
No, it is, there are several such instances, but it is basically people like De Morgan and Charles Brown and to some extent Winternitz who are really responsible for more willful abuse or sort of talking ill of the work of Whish. The first two by especially talking, directly talking suspicious things about his work. And Winternitz really neglecting the Malayalam, most crucial Malayalam manuscripts of Whish collection. But these are various famous Indologists. I mean, you can start with Thibaut. Then we have this Surya Siddhanta translated by Burgess and Whitney. All these people, then there is another John Burgess. All these people are referring to the article of Charles Whish. Either the 1827 article, sometimes even the 1834 article, but they're referring to it in some other context. So the material that is contained in Wish's paper is not talked about at all. So Thibaut writes a German history of Indian astronomy, astrology, and mathematics for a handbook sometime in 1890. He's a very reputed and high level scholar in Europe. And there, the article of Whish, which says the Indian Rashis are borrowed from Greek, is mentioned very prominently. But nothing that Whish has said on Kerala astronomy mathematics doesn't even find an appearance. So like this it goes. But what is strange is even historians of mathematics, like David Eugene Smith of Columbia University, he is one of the most important historians of mathematics in the first quarter of 20th century. So he writes two important, one article in 1930 on history of geometry, where again he refers to Wish's article of 1834 on the quadrature of circle in the end, but there is no link to it in the article itself. And he is talking again of Bhaskara being the last great geometer of India. I mean, that is Bhaskaracharya 2 at 1150. This was a general myth which was created that Indian mathematics died out after 11th, 12th century. So Bhaskara is the last great geometer of India. Then David Eugene Smith has written a 2-volume history of mathematics, a highly cited work. So in the second volume, he is talking of values of pi in different civilizations, and he talks of the Hindu values of pi. So there he gives a footnote for some more discussion on Hindu values of pi. See the article of Whish on the general subject of Hindu quadratures. See C.M. Whish on the Hindu quadrature of circle. A paper read before, he says, Madras Literary Society, December 15, 1830. Anyway, it was not read before Madras, whatever it is. So even he is very hesitant to go into this content of this article. It's not that this article was not available to David Smith, but he's not wanting to go into the content. But I think he did a great service by putting it in his history of mathematics. So many Indians who were starting to read history of mathematics and see the literature immediately got to the article of Whish. And that is how Vibhuti Bhushan Datta writes an article on the Hindu values of pi, where he takes the material from Smith also and writes much more detailed article on ancient Indian values. Then he goes to the article of Whish also and recounts whatever all the Kerala values of pi and the infinite series for pi. And he says, I do not at this stage have access to the original manuscripts of these works. I should say something about Vibhuti Bhushan Datta. I mean, we can forget about these European scholars who hemmed and hawed, referred to Whish and didn't talk about its content. So a new era begins with this paper of Vibhuti Bhushan Datta in 1926. Vibhuti Bhushan Datta does a PhD in Calcutta University, and from about 1920, around the time when he even starts his PhD, he has interest in Indian mathematics. So he starts looking at all available older Indian works. He's quite a good scholar of Sanskrit by then. And so by 1926, he already knows a whole lot. And so in 1926, he writes this article in the Calcutta Bulletin of the Calcutta Mathematical Society on the Hindu values of pi, where you see all these infinite series of Whish for the first time in print. The last time they appeared in print was in De Morgan's Encyclopedia article in 1843. After that, these infinite series had not appeared in print at all. Earlier, it was in Wish's article of 1834. Datta's collaborator, Avdesh Narayan Singh. We know Datta and Singh is the famous history of Hindu mathematics, the 2 volumes they published in 1935 and 1938. Avdesh Narayan Singh writes an article on the use of series in Indian mathematics and Hindu mathematics. And in that article, by then these people have gotten hold of Sadratnamala manuscript also and Karana Paddhati manuscript also. So he quotes the verses for the sign series and all that and gives the sign series, which is not contained in Wish's paper. Wish mentioned that Hindus new science series, but they didn't. So this is how this whole iron curtain, so to say, is broken, or glass ceiling is broken, or whatever. And after this starts a new kind of effort. From this Datta and Singh, they themselves had collected quite a few manuscripts. And this articles of Datta and Singh, and at the other end, in Kerala, people start publishing. The book Karana Paddhati is published in 1937. In fact, Sadratnamala had a reprint in 1893, but nobody took note of it. It was published in Kerala. It didn't come into the notice of the mathematics experts. But 1937 Karana Paddhati is published, and this Prince Ramavarma Thampuran in Kerala and his collaborators start looking at Yukti Bhasha. They start preparing an edition of Yukti Bhasha. They collaborate with Professor C.T. Rajgopal, who is in Ramanujam Institute of Advanced Study in Mathematics in Chennai. And initially he is in Madras Christian College as a professor. So in that period, in 1940s, his student Mukunda Mara from Kerala first writes an article in 1940 in Cochin Teachers Magazine, translating the proof of the Mādhava series for pi, or whatever Leibniz series for pi. The complete proof of that, he translates it into English and publishes it in 1940. And a later version of that paper, and with much more material, is published. The Cochin Teachers Magazine obviously would not be easily accessible. So in the Journal of the Bombay branch of Royal Asiatic Society in 1944, C.T. Rajgopal and Mukunda Mara write a paper on the Hindu Quadrature of Circle. There they mention that this is actually a successor to 1834 paper of Wish. Wish said he will publish the proof of all these series. We are going to give all these proofs of this series as given in Yukti Bhasha. So they start with this article and write about half a dozen articles between 1944 and 1952, both in Indian journals and in journals abroad. And that way, the proofs of all these series are published from Yukti Bhasha. And Mukunda Ramavarma Thampuran and Akhileshwara Iyer, they publish the Yukti Bhasha Malayalam text as it is, with the detailed Malayalam notes. And so the original text get published, and that way the material is now available. The Malayalam work is still available only in 1948 in Malayalam, with the Malayalam commentary, modern Malayalam commentary and modern mathematical commentary in Malayalam. So this was the situation in 1950. Then Indian scholars start taking note of this original work of Rajgopal and his collaborators, and the book of Ramavarma Thampuran, whosoever could read Malayalam, like Saraswati Amma and others. So a host of writings come in 1950s. First by C.N. Srinivas Iyengar in Kannada. He writes a book on history of mathematics in Kannada, Ganita Shastra Charitra, in 1958, where he gives a complete, half the book deals with Indian mathematics. C.N. Srinivas Iyengar wrote later a book in English in 1969 on history of Indian mathematics. So there he discusses the Kerala work in detail, as discussed by Rajgopal and others. Some European scholars, Hoffman, later on Whiteside, and later on this Margaret Barron, who writes a history of calculus in 1969, and also H.L.L. Bussard, who is a major German historian of medieval mathematics. So there are various articles in Europe, and there is a Russian scholar who writes history of medieval mathematics. So there also you get a detailed version of Kerala mathematics. And in India, Saraswati Amma, Srinivas Iyengar and A.K. Bogg, they write articles. So emerges a new era in the history of Indian mathematics, that the Kerala work, which was sort of completely kept under wraps for more than 120 years, now is available with some portion of the original being known. And we can say there's an emergence of a new era.
With Charles Whish being truly an ambassador of Indian mathematics and so to say Kerala School of Mathematics, I think from 1930s onwards, when the introspection started, our Indian scholars took up from Vibhuti Bhushan Datta and from Ramavarma Tamburan, I would say you and your colleagues, the work is still ongoing. But in between, I believe your previous generation, you had the good fortune of having the guidance by the stellar Professor K.V. Sharma, who also had done a lot of, spent a lot of his effort in his life effort in unraveling the gems of Kerala mathematics, the monumental contributions. So can you also please speak some of the landmark contributions that Professor K.V. Sharma did in this area?
Between the first publication of a Kerala source text, a source text of Kerala mathematics, was actually in 1874. But that was not one of the four texts that Whish mentioned. That was a commentary by Parameśvara on the great ancient text of Aryabhatiya. So from 1874 till 1946, about 10 original source texts of Kerala got published. Amongst them, the work which had some mention of this Kerala work on infinite series and calculus. One was the Sadratnamala with Shankaravarman's auto commentary, and the Karana Paddhati, the work of Puttumana Somyaji on the Vakya system, which was published by Samba Shiva Shastri in 1937. But from 1931 onwards, the Aryabhatiya Bhashya Nīlakaṇṭha Somyaji also started getting published. The first volume was published. The second volume, the Ganita Pada and the Kalakriya Pada commentaries were published. But even after the publication of Yukti Bhasha by Ramavarma Thampuran in 1948, people were not clear what is the name of the author of Yukti Bhasha. It was not known when did Mādhava, what was the period of Mādhava. So like this, the entire history of this school was still to be researched upon, because unless you look at all their works in total, you will not be in a position to sort of give a narrative. And so it was this lacuna and the publication of many of the most important original works. This was what was filled by Professor K.V. Sharma, the late Professor K.V. Sharma. He was born in 1919 and he had a BSc in Kerala and he was born in Kerala only. And after BSc, he took a master's in Sanskrit. Then he came to Madras with the Catalogus Catalogorum project. He was there till mid-1950s. And then he went to Hoshiarpur, where there was an Indological Institute. He became the director of that till 1970. So it was in this, from 1950s onward, Professor K.V. Sharma did an extraordinary amount of work in bringing to light the original works of the Kerala school and bringing a narrative of the entire history of this Kerala school. So in 1972, he wrote a history of the Kerala works in astronomy and mathematics. So there he had listed about nearly 400 works on mathematics and astronomy, of which about 150 happened to be in Malayalam. And mostly half of them were Karana texts. Karana means astronomical manuals, calculational manuals. But there were 6 Siddhanta and 34 Tantra texts. 30 years later, in 2002, he did a survey of Sanskrit science texts in Kerala and Tamil Nadu. So he identified about 450 Sanskrit texts alone on mathematics and astronomy from Kerala, which was available in the public repositories, manuscript repositories of Kerala and Tamil Nadu. This was published by Rashtriya Sanskrit Samsthan in 2002. So Professor Sharma himself published about 19 works of the Kerala school. And then he also published one compilation called Ganita Yuktaya. These are very interesting works. These are like the Kroda Patras in North India. These are small tracts where you take up some topic and write a note, either a proof or ask a question or solve a problem or present a new way of discussing something. So these are Ganita Yuktaya. These are basically texts of presenting demonstrations for some of the astronomical and mathematical procedures. And this book contains 27 small tracts. These were written from 16th to 19th century by different authors at different periods. In fact, it contains a very important short work of Nīlakaṇṭha Somyaji. This was, in sum and substance, the extent of contribution of K.V. Sharma. The main portion of K.V. Sharma's inquiry was to look at works which present proofs or yuktis, they are called in Kerala school. The name given is Upapatti in the older text in Indian tradition. They are called as Upapatti by Bhaskaracharya also. But yukti is a more common name used in the Kerala school for these proofs. Vasana is also a name used by Bhaskaracharya for this proof. So K.V. Sharma first published two Sanskrit works, Kriya Kramakari and Yukti Deepika. These are commentaries by Shankaracharya written around 1540, 1550. These are commentaries of older works, Leelavati and Tantra Sangraha. Leelavati of Bhaskaracharya, the mathematics work, and Tantra Sangraha, Nīlakaṇṭha. They are very detailed commentaries which give all the proofs of all the results. Then he was looking for presenting a complete edition of Yukti Bhasha of Jeshtadeva, the work I mentioned, which was actually a textbook kind of a thing, covering the entire of mathematics and astronomy, the entire contributions of from Mādhava to Nīlakaṇṭha. It is meant as a larger exposition of Tantra Sangraha, though it's not a commentary on Tantra Sangraha. And there was the mathematics part edited by Ramavarma Thampuran. So K.V. Sharma managed to make an edition of this. He spent about 15 years trying to work on an edition and a translation. And then he wanted us to collaborate, Professor Sriram, Professor Ram Subramanian and myself, to write some mathematical notes, try and formulate it in terms of equations and diagrams and in terms of well-known astronomical ways of presenting things. And so this really got completed only around that time when almost he was sort of doing it in his last days, the final version of it. It got published 2 years after he died. In 2005, he passed away. In 2008 and 9, these were published. But now, this Yukti works that K.V. Sharma has been able to put together, they show something very interesting, because now we have the way the Indians present their arguments, Indians present their proofs. Earlier, we had only various examples of such proofs in commentaries of Leelavati, written by Bhaskara himself and by Ganesha Daivajna, and Bijaganita commentary written by Krishna Daivajna, and some other kinds of proofs in works of our Govinda Swami's commentary on Mahabhaskarya. These were all older sort of works, but these Kerala works really are very elaborate in trying to write down the proofs. So we are able to understand how all these new results on infinite series came, and how the series were manipulated, how they were understood, and what was the way in which these proofs were made. When modern scholars started analyzing them, it became clear that they were indeed much more rigorous than the proofs that were provided when such results were rediscovered in Europe in 17th century. In fact, when these results were rediscovered in Europe in 17th century, it was more by abandoning the old Greek notion of rigor that Europe could proceed into the new era of calculus. In fact, this is written by all historians of mathematics, that if Europe had not accepted real numbers, etc., had not accepted the ways of arguments that Newton, Leibniz, and all these people wrote, which were not exactly following the canon, Euclidean canon of proofs. They were more intuitive arguments with various steps missing and all that. If this was not accepted or acceptable, then mathematics, calculus could never have come into being. This is how modern historians of calculus write. But that was not the case in India. Indians followed the same level of rigor that we find in the arguments of Bhaskara's Vasana or Ganesha Daivajna's commentary. The same thing is continued in the Kerala works. They use recursion, they use induction, and they take limit by a very careful way of looking at the order of magnitude. So all this was to come much later in Europe in 19th century, when they started trying to understand the notion of limits in a much more systematic way. The period of 17th and 18th century, from Wallis to Newton to Leibniz to Euler, etc., is a Bernoulli's and all. It's a period of great discovery. A lot of new things are discovered. Now all those proofs have to be systematized, and that is what happened after 19th century, Cauchy, Daly Chain, various. That's a different story. But they are more like the modern proofs. But they are different from the modern proofs. In fact, one of the recent estimates of Kerala mathematics is Kerala mathematics in the 14th to 16th century. This culture was the most advanced mathematical culture of its time throughout the world. Its breakthroughs include the power series, etc., etc. Now, some historians of mathematics earlier said that Indians had no interest in proofs. Of course, this is not true. There are proofs even in earlier Sanskrit works. But with Kerala's tradition, more elaborate proofs survive in the Indian sources which come from Kerala. But Indian proofs do not start with axiomatic foundations. Indian proofs could rely on evidence elicited from observing a diagram or using analogies to physical situations, etc. So today, mathematicians do discover that there is a different methodology Indians are adopting, though we will have to look at many more texts to really understand the details of this methodology. But these proofs are as rigorous as they can be. They can taught to today's college students, but they are not formulated in the way Euclidean proofs are formulated. They don't use axiomatic methodology. They go from known results to new results, but they do not write down one set of axioms once and for all. But much more crucially, they don't use what is called reductio ad absurdum technique. That is, you try to show that something is true by proving that the opposite of this is in contradiction with something that you know. This is all right in many situations, but supposing you want to prove the existence of something, the existence of something is proved by trying to give you a method of how to find that thing. Existence of a solution to an equation will be a meaningful result if you give a method to solve that equation. But if you only show that the non-existence of the solution to that equation contradicts with the other results that you know, you are no wiser about the solution than before. So such proofs are called non-constructive proofs. They are not accepted in Indian mathematical tradition. This is a major topic in today's mathematics. This is one kind of work of Professor K. V. Sharma's consequence of his work. The second kind of a thing was K. V. Sharma was interested in bringing out works which were saying new methodologies in astronomy, new techniques in astronomy, either in eclipse calculation or in planetary models, etc. So while he was engaged in the edition and translation of Yukti Bhasha, he noticed that Yukti Bhasha was discussing a new model of planetary motion as formulated by Nīlakaṇṭha. So he wrote that in an article in 1991 with S. Harihara. But this new model of Nīlakaṇṭha is much more discussed in much greater detail by Nīlakaṇṭha himself in his works Tantra Sangraha and Siddhanta Darpana and Aryabhatiya Bhashya and works like that. So this became more well known when Ram Subramanian, Srinivas and Sriram that we wrote a paper on it in 1994. And afterwards, the entire work Tantra Sangraha has been fully analyzed in the publication of Ram Subramanian and Sriram. And in several other later works, this model of Nīlakaṇṭha has been analyzed in great detail. One thing which has been shown that is that computationally it is a close approximation to the Keplerian model. In fact, though the cosmological model looks like the model of Tycho Brahe, the computational model of Nīlakaṇṭha is that of Kepler. Tycho Brahe's model is only Ptolemaic model rewritten with heliocentric cosmology for planets and a geocentric cosmology for sun and the planets together. They have also shown that lots of works have shown that later Kerala astronomers followed this new model of Nīlakaṇṭha. For instance, especially Achyuta Vishavarati has several works which uses the new model of Nīlakaṇṭha Somyaja. So what has gotten established due to the work of K. V. Sharma and many people is that today we now know that the Kerala school during 14th to end 15th or early 16th century, in this about 120, 130 years, it came up with the two of the most important inventions, the discovery of calculus. I mentioned only infinite series, but there was also the idea of instantaneous velocity and that as the derivative of the position. So this was known to Nīlakaṇṭha. This was even known to some extent to Bhaskara himself. So this discovery of calculus and discovery of non-geocentric planetary models, these two, which happened between 1540 to about 1610, 1620, and calculus actually goes up to 1670. So these which happened in 16th, 17th centuries in Europe, and they have been hailed as the first hallmarks of modern European scientific revolution. They were there clearly in the works of Kerala school. The final important concern of K.V. Sharma, he kept on looking at works which discuss the methodology or the way they look at scientific theories or astronomical theories, and what is the role of observation and theory in them. So he was looking for works which talk about the need for accurate observations and things like that. And there are several, this was well known in ancient Indian texts also, but this matter is very much discussed in the works of Parameśvara, Nīlakaṇṭha, and Jyeshtadeva. But what K.V. Sharma succeeded was, he was lucky to find out a text of Nīlakaṇṭha, though the entire text is not available, a part of the text is available. It is called Jyotirmīmāṅsa. This book, this work especially deals with the epistemology of Indian astronomical tradition. So in this work, Nīlakaṇṭha emphasizes that the planetary theories of Aryabhata and all the ancients are only human constructs. They should not be thought of as divine revelations. In fact, the divine grace, according to Nīlakaṇṭha, plays a role only in ensuring the clarity of intellect of the investigator. Similarly, the other crucial thing that Nīlakaṇṭha is emphasizing in Jyotirmīmāṅsa is that all ancient theories and even current theories should be continuously examined by observation. And this method he calls as pariksha. And he says, when you teach a student, you don't teach a scientific theory as a finished product. You give it to him saying that this is to be subjected to further examinations and further improvements by you. This is how a scientific theory is to be taught. So these are the two things. There are just two quotations I will just say. So first one is concerning, he says, didn't Brahma tell Aryabhata all those numbers which are used in astronomy, and Aryabhata just only compiled what Brahma taught to him. So what is meant by altering it? Tasya kutha parikshana Brahmanaha sarvajñatvat ragadveshadi abhavacha manda maivam devata prasado mati vaimarya hetureva. So it is not that Aryabhata had a divine revelation and wrote down those numbers. The divine grace was to ensure that Aryabhata, with a clear intellect, could sort of navigate through the complications and find out the correct causes and the correct numbers and the correct models, etc., from the multiplicity of possibilities. Similarly, his other argument is that Pancha Siddhantas tavat kvachit kale pramanameva ityavagantavya. Various Siddhantas were quite all right in those times. Apicha yaha siddhantah darshana visamvadi bhavati so anveshaniyah. So we have to look for that theory which is in consonance with observation for our time. And darshana samvadascha tadanitanehi parikshanehi grahanado vijñātavyah. And this has to be understood by people who do these examinations during the times of eclipses or other various times. And therefore, Bhede sati yantraihi pariksha grahanam bhaganadi jnatva abhinava siddhantaha praneyaha. So that is the objective that should be kept before any generation. Tasmat shishyanam grahagati samarthyapadanameva shastra prayojanam. The shastra is to be taught to the student so that they are able to examine the motion of the planet. Not understand and calculate the motion of the planet as told by the teacher. So these are actually today in modern scientific epistemology, these are considered highly revolutionary, because as we know, when the modern science came, everybody from Kepler to Galileo to Newton thought that they were discovering the laws of nature as ordained by the creator at the time of creation, that they were divinely ordained laws of nature, which humans were trying to get it for the first time. Whereas Nīlakaṇṭha around the same time, in fact even 100 years earlier, is talking of Devata Prasado Mati Vaimarya Hetureva. Similarly, they thought they had found the ultimate reality of classical physics. Only in 20th century, we think that the theories are under continuous test and new revolutionary changes can occur in theories. So this is a lesson that is being thought of in modern. So these are all inherent things in Indian scientific epistemology, which is being discussed in a very, very incisive manner in Nīlakaṇṭha Jyotirmīmāṅsa. And this is a great discovery of our Professor K.V. Sharma, that he was able to bring out such a work. That has been the contribution of Professor K.V. Sharma.
In your exposition, actually, you have brought out the intellectual tradition and culture of this country. Because I'm reminded of this text by Lalla, Shishya Dhivriddhi Tantra, who kind of discusses similar questions, and refutes the already existing way of acquiring knowledge, how the knowledge should be transmitted. And here you're talking about Nīlakaṇṭha, who comes much later and resonates the similar thoughts. So it shows how the intellectual thread continues in our culture. But at the same time, I'm also equally sad that even after this much of extensive work by Professor K.V. Sharma, or that by you and your colleagues, we don't get to see these Indian names in our textbook. But at least now under NEP 2020, there is some hope. So what are your views on bringing some of this Indian mathematics, or particularly Kerala School of Mathematics, in the scholastic framework?
No, this is again a very timely question, but this is a sad issue that even 75 years after independence, we are discussing how sort of Indian civilizational knowledge is to be brought into our schools. And as you know, the whole error goes back to around 200 years, when it was not merely Macaulay who said that Indian Shastras have no relevance for today, and therefore we should not teach them to our students. He said that the Indians want to learn our modern knowledge. And so people like Rajaram Mohan Rai, when they wrote to the British Governor General, they seem to have committed this great blunder, that they said that this Sanskrit corpus is what has kept India in darkness. I mean, they bought the whatever theories Europeans had taught them in the previous 30, 40 years in Bengal. And they did not say we take our older books and add new things or new discoveries and make newer books. They said you forget about all that, you let us be taught in English and taught from scratch the knowledge as it is, without any reference to our past knowledge. And if our past knowledge is to be referred to, it should be referred to derogatorily as saying that they were believing in Rahu and Ketu, some demons causing eclipses or things like that, and not the scientific astronomy or whatever. So this education system needs a thorough rehaul as regards introduction of our Indian civilizational knowledge at every level, from the school level to the college level to the research level. So perhaps such ideas are incorporated, are suggested in the new educational policy, and I think Government of India is taking various steps to initiate some action along this direction. I'm sure you're also in BHU with an Indian Knowledge System Center and things like that. So we can hope that the next generation will not be talking about these things in this area. But the situation is actually not very rosy in terms of what we know about Indian. In fact, the problem about communicating Indian knowledge traditions is there has been a sampradaya vicheda, a functioning, flourishing knowledge, got stopped at some point, and we have sort of kept it at that point. And many of us have forgotten most of it. And many of us have forgotten its true interpretation and all. And we are learning new things with no relation to that. There are, of course, various disciplines like Ayurveda or philosophy, music or arts, and our linguistics to some extent, if it's learned traditionally, where we are continuing with the older knowledge in some manner and perhaps adding to it in a systematic manner in Ayurveda and things like that. Because in the COVID time, I have seen that Ayurveda has been able to very successfully handle hundreds of cases of COVID. Anyway, as regards the Kerala works on astronomy and mathematics, what we know today is only a fraction of what has been done in Kerala school. K.V. Sharma had listed 400 to 500 original texts. So as I mentioned, before 1874, none were published. In the first era of modern Indology, 1800 to 1874, no texts were published. 1874 to 1946, about 10 to 11 texts were published. In the post-independence era, some 55 texts have been published, and about 10 have been translated to explain their technical content. So out of these 500 works, we really know the technical content analyzed and discussed for only about 10 works. So this is our situation. I mean, it's not that every new work may be like Nīlakaṇṭha's Tantra Sangraha, or every new work will be like Mādhava's Venvaroha. That may not be the case. But you will know how they were understood, how they were studied, how calculations were made. So we have to quickly look at, and the situation will be similar about the larger astronomy and mathematics corpus of manuscripts. Some other study I had made a couple of years ago shows that we have only published only about 5% of the astronomical and mathematical texts out of some 9,000 works, some 450. And of that, only about 1/5 have been translated, etc. And the situation will be much worse for other subjects like chemistry or even for philosophy. I think the number of works which are to be looked into are very large. So who is going to look at all of them? K.V. Sharma was not appointed to study this. That he happened to do this was by his personal voluntary interest. And that was the case with Vibhuti Bhushan Datta and Avdesh Narayan Singh, Ramavarma Thampuran, etc. But they were prior to the era of Indian independence. But today in India, with about 2 crore children entering portals of higher education and 10 crore children entering all education every year, and we have lakhs of colleges and thousands of universities and institutions of higher learning. Unless these subjects are studied as topics of research, unless these sources are all looked into, I have talked about literary sources. There are observatories and things like that. There are physical sources in metallurgy. There are older objects, and there are older structures for archaeology, architecture, or chemistry and things like that. So unless all these are preserved or looked into, analyzed, documented, that is one kind of research. Then they are related to what we know otherwise in modern knowledge gain. We arrive at a unified understanding to move on. We update ourselves on the basis of what we know. In fact, we should undertake something like what Raja Jai Singh did in 18th century. What he did was, he found that the various texts from which calculations were made were not accurate. So he went ahead and started constructing huge observatories. And then he translated the latest Islamic works. And he was not satisfied with that. He sent some of the Portuguese to go to Paris and pick up the Dilahir tables of 1710. And this he discussed, got it translated in 1720s, late 1720s. And in 1734, he is writing to the Jesuits. I am trying to, with my observatory, I am trying to do observations, but your tables are not coming out to be accurate. I see this much discrepancy, etc. And then he is getting his Samrat Jagannath and various people to write new books in Sanskrit. Apart from translating the foreign texts into Sanskrit, he is writing new books in Sanskrit, discussing new parameters, new methodologies. Only this was a brief phase from 1710 to 1740. He was in Jaipur. He got the new city of Jaipur built on old architectural principles with a sthapaty. So this would have been a renaissance if we could have continued it. So in some sense, what we need to do is what he did, update all the Indian civilizational knowledge. Maybe the gap is more in astronomy, gap is less in mathematics, gap is even less in medicine, because Indian medicine has its own methodologies and all that, which if it updated, they would have come up with cures like the Chinese came up in the case of malaria and even got a Nobel Prize for it. So many things are possible, and we will have to have our higher institutions of learning involved in documentation, research, and more than anything else, teaching courses. So, and training students with PhD and all that. So unless those are not, then textbooks don't get written. And at the school level, we will have to give some indication of what they are learning. In fact, most of our school mathematics is actually either originated in India or became much more developed in India. So, but we have no indication by going through our school book that what Brahmagupta did on algebra. We study only a fraction of that in our school. It is much more than that. Or in cyclic quadrilaterals, or in combinatorics, or even in geometry itself. Or all our arithmetic algorithms are originating in India. So we know nothing of all this. It's not merely telling it as history. They had wonderful, beautiful examples given in all our ancient books. If we even pick up a small fraction of them and teach it to our students, they link themselves both with ancient culture and even our contemporary Indian reality. These examples sort of resonate much better with our children. And there are many interesting fine things like magic squares, etc., which our people discuss, which we don't teach to our children. So hundreds of things are possible. If only we determine that we are going to bring in all our past knowledge and we are going to update our knowledge. We don't stop like this by saying out of 500 manuscripts, only 50 are seen and 10 are translated. In a generation or two, this situation can change. And then we can confidently first talk about our past, then we can update it and then apply it for contemporary situations. Professor Takao Hayashi, he has retired now. He was the very famous professor of historian of Indian mathematics also. In his website, he had put up a note saying that Japan has been following the modern Western science from 1850s or whatever, from the post-Meiji period. But modern Western science is only one of last 100, 300 years. And it is neither the ultimate of all science. In future, there will be many more discoveries, and modern science is only a transitory phase of science and technology. So for Japanese to be able to contribute to even for this future science, we need to know really not only about the past of our own culture, but also other similar cultures like China and India, their sciences, their mathematics, their astronomy. Because the future science will not be the same as the today's science of modern West. So this simple understanding is what should take us forward. What Nīlakaṇṭha is saying the same thing, that the older books are all right. That is as much applicable to today's books also. So today's scientific theories are all right, but they will not be tomorrow's scientific theories. And they are not divinely ordained theories. They are all products of human ingenuity, human effort. And they are products of different cultural orientations and different sort of situational needs and aspirations of different societies. So the future sciences will move in the way society move. And if Indians reacquire the spirit of Indian civilization and want to carry it forward, they need to be really informed, not only about the details of science and technology done in India, but even the spirit, its philosophy, its worldview with which it was done. So that not necessarily to be stuck with a worldview or with a philosophy, but to understand from it. And Indians have always said that our understandings are only approximate, and therefore the future holds unlimited sort of vistas for us. But then we will be carrying forward the Indian civilizational knowledge to the modern period, and that will be a resurgence of Indian civilization.
The scholarly exposition by Professor M.D. Srinivas, at least the naive enthusiasts will not propagate the statement that India's contribution to science is only zero. This, I'm sure this conversation that we have had, the audience will agree with me when I say that this is not just a lesson on or a peep through the Kerala School of Mathematics, but it is also a lesson on historiography, biography, heavy dose of history, and several interesting facts that had happened in the last 200 years. And yet, Professor is very optimistic as to what is to be done in the future. So on that optimistic note, I, on my personal behalf and behalf of Atharva Forum, thank you, sir, extensively for your scholarly exposition and the time that you have given to all of us. It is Balanam Sukhabodhaya. So it is in that sense that you have given us this time and your effort.
Very kind of you, patiently heard whatever I had to say.
Thank you, sir. I request the audience to subscribe to the Atharva Forum YouTube channel and press the bell icon for notification on latest video uploads. Namaste.